Okay, now recording. All right, so we are all the way up to here. So 7.4. So the game plan for today was 7.4. Okay, and once again, if I happen to finish early, which I think I will, then I'll leave it open to a question and answer session. And if there aren't any questions or answers, you can just go ahead and leave after that. Okay, so reminder, our next exam is this coming Thursday, 2 days from now. It'll cover chapters 5 and 6. We are already way past that. Okay, there will not be any chapter 7 stuff in the test, although, you know, a lot of trig tends to get mixed together. So a lot of the stuff that we're doing kind of reviews for that material. Okay, so quick reminder of ground rules. You turn in for homework, everything here and here. There's a 70% homework requirement. I end up doing a huge percentage of it anyway, so it's really not that hard to do at least 70%. Okay, and again, I only promise you 50 minutes, but if we finish lecture early and then I'll let you ask questions on Thursday also, but if that stops like the last time, we can just have more time for the test, and that'll be perfectly fine by me. Then that just gives you more time to finish. Okay, I will close the class at 1 o'clock as usual. Then you have until 1:05 to take pictures on your cell phone, just like, you know, just like the quizzes, and you've already done a couple of tests already. And then I'll give you another half an hour, so until 1:30 to submit the homework. But you may turn in the homework early. So after class ends tomorrow, the 17th, then I'll let you submit the homework. If you already have the homework ready after class, I'll take it anytime from after class tomorrow until Thursday, the 18th at 1:30. Okay. Usually give about 10 questions. So most likely scenario is we have 10 sections, right? 5.1, 2, 3, 4, 5, 7, and 6.1, 2, 3, 4. That's 10 sections. So a very likely scenario is I give one question from each section, and then that would be the test. You can have one formula sheet, one cheat sheet, regular standard size paper, 8.5 by 11. You can put anything you want on both sides, but after that, no other helps. So don't use any other people. Obviously, don't use the computer, online, books, notes, anything besides that. Okay. Remember, I reserve the right to question you about it later. So if I suspect cheating, I can ask you about it one-on-one later, and maybe just have a one-on-one Zoom session and ask you, okay, how did you do this problem? How did you do that problem? And if I see that you can't answer like you did on the written part, then I might decide to grade your oral exam more heavily, okay, if I suspect that some cheating went on, okay? So that's the way that works. So any quick questions about the test, you can either unmute yourself or put it in the chat. Otherwise, we'll go ahead and get started with 7.4. Okay, I don't see or hear anything, so we'll go ahead and start. All right, so 7.4, the topic is algebra and the trig functions. So it's not really any new section, but just kind of reviewing stuff. So algebra and the trig functions. So all the rules that we had in algebra still apply to trig, but we have the trig functions on top of that. Okay. So the assignment was 1 to 65 odd. As usual, you'll probably see me end up doing about half of it. And that's the game plan for today. Okay, again, if I finish early, you can either stick around for questions and answers for the exam, or you may leave after that. Okay. A lot of the problems are paired. They do an algebra problem and then a trig problem, which is sort of like the same algebra problem on top of that. Okay. Let's see. On page 504, to give basic trig identities. Okay. And a lot of these actually could apply to this test. Yeah, in fact, 1, 2, and 3, if you want to put those on your cheat sheet, you may. Looks like we're going to have a lot of that. And then the examples, you don't really need the examples, but they're nonetheless true. So if you haven't already done so, I would say put 1, 2, and 3 right there on page 504 on your cheat sheet. All right, so We had 1 to 65 odd. So again, let me show it to you for the benefit of those of you that don't have the book, page 507. So 1, 3, and 5. Okay, again, it's not meant to be giving you a lot of time so you can copy it down. I'm going quickly, just enough so even for a split second, you can watch the video and get it later. For those of you that don't have the book and aren't planning to get it. Okay, just so that there's some time that you can, fast forward, you can pause as much as you want, rewind as much as you want, play back as much as you want. Just give you enough so you can kind of see it. 7, okay. And then on this side, somewhere there, okay, that looks like stuff we've done before. And that looks like stuff we've done before. So this is actually a nice review for the exam coming up. Somewhere there. And I think that's it. I think we have to go up to 65. So I believe you can see all of that right now. Okay. Okay, so 7.4, page 507. And I don't know why I'm writing in green. I don't want green right now. Okay, 1A. Negative SC plus 12 SC. So from algebra, you just combine like terms. That's negative 1 plus 12, which is 11 SC. But the reason why they're doing that is they pair it with B, negative sine theta cosine theta plus 12 sine theta cosine theta. Okay. Even though they put it in terms of trig, these are pretty much the same kind of problems. These are like terms. Okay. In fact, there's a reason why they put the SC. Can you see what they have here? Sine and cosine. Okay. Now, even if you didn't know anything about sine and cosine, just think back to your algebra 1 class. Say, oh yeah, negative SC plus 12 SC, that's 11 SC. Okay. So now if you just kind of replace it with sine and cosine, negative sine theta cosine theta plus 12 sine theta cosine theta, that's 11 sine theta cosine theta. In other words, just because we're in trig right now doesn't nullify all the rules that we had before in algebra. Okay. So that's what they were trying to show you with that. Okay. And there are a lot of other problems that are similar to that. Okay. So 5A says 1 plus t squared. Okay. So I'm going to use a shortcut formula. A plus b squared is a squared plus 2ab plus b squared. I'll box this off. So this is an application of this law. So 1 squared is 1. 2ab, 2 times 1 times t is 2t. And then my b squared is t squared. Okay. Then part B, okay, I claim this is really the same thing as this, and there's a reason why they picked t. Pretend it says tangent, right? Tangent theta. So you're just doing the exact same thing here. So 1 plus 2 tangent theta plus t squared, tangent theta squared, but the way you normally write it is to put the 2 like so, tangent squared of theta. So that's the way you should write your answer. Okay. All right, so they give you the algebra version, then they give you the trig version, and they tend to use the same letters just to help you out with that. Okay. 9, you may or may not remember this. S minus C divided by C minus S. Okay. So let me get rid of the curl here, sorry. Okay. Are these the same? Can I cancel them out and get 1? Okay, the answer is no. It actually turns out to be -1. And I don't mind if you put something like that in your cheat sheet, although I don't think you'll need it for this particular test, but for the next exam. This comes out to be -1. Okay. You can pick any numbers that you want as long as C and S are different. If they're different, you can show they're always the same. Or maybe I'll just plug in something like 3 and 10, 10 and 3, for example. Like, what's 3 minus 10? -7. What's 10 minus 3? +7. So when you divide them, you get -1. Okay, so this is -1. And can you guess what they're going to put here? They just do the same thing with sine and cosine. Okay. In fact, I'm sure they picked S and C because sine and cosine. So in other words, just because you see a whole bunch of trig stuff, it still fits this same pattern. -1, right? Sine minus cosine, cosine minus sine. If you divide, you get -1. Okay. All right. So that's how that one goes. All right, now some factoring problems. So you can factor with trig also. So 13a says t squared plus 8t minus 9. Remember factoring? T squared is t. What two numbers have a product of 9 and a difference of 8? Well, it's got to be 1 and 9, right? So 1, 9. Let's see, you want to end up with a +8, so the positive should go with the larger number, plus 9. And of course, you can FOIL it back out to double check to see if it works. Okay, double check. T times t is t squared, plus 9t minus 1t is a plus 8t, and there's the minus 9. Okay, so it definitely works. B, they're going to do the same thing. Can you guess what we're going to put instead of t? Tangent, right? Tangent squared theta plus 8 tangent theta minus 9. It's really the same problem. Okay, or actually, sorry, they put beta there instead of theta, but it's the same thing. Let me change it to theta. Tan theta, 9, 1. You pretty much just copy what you have here, minus and a plus. Okay, yeah, I didn't look at it carefully enough. They really had beta, but the principle is the same. Beta is a funny looking B. So I'll tell you what, I'll just sneak it in up here in red. It's supposed to be beta. I automatically put theta. I thought it was beta, but anyway, theta. Okay. Okay, 17, similar thing. 9s squared t cubed plus 6s t squared. Okay, factor. So 9 and 6, I can take out a 3. S squared and S means I can take out an S. T cubed and T squared, I can take out a T squared. Right, left behind 3ST. How do I go from 3 to 6? 2. S, don't need anything. T squared, don't need anything. So that's it. Okay, this time for S and T, they use secant and tangent, but otherwise it's the same thing. Okay, and unfortunately I reached the bottom of my paper, so I can't show you the contrast, but it's essentially the same thing. So we have that. Going up for B, 9 secant squared. Let me make sure they're using the right letter here. Just going to use B, 9 secant squared B tangent cubed B plus 6 secant B tangent squared B. Factor. See, they're not really hiding anything, right? Just call that secant, call that tangent, and you're doing the same thing. So I'm just going to copy this, essentially, except write it in its trig fashion. So it's 3 secant B tangent squared B. That's like 3 secant tangent squared, 3 secant tangent squared. 3 secant tangent plus 2. 3 secant B tangent B plus 2, like that. Okay, and sorry, I can't show you both at the same time, but still, it's essentially the same thing. Okay, factor that into 3st squared, 3st plus 2. So 3st squared. It's a little bit more complicated because of the trig, but same concept. 3st plus 2. So there we go. Okay. Okay, that's that. Now, the next set of problems, write in terms of sine and cosine and simplify each expression. Okay, so they give you these big monstrosities, okay, but change everything to sines and cosines and then make it nicer. That's what they're trying to say. Okay. So how do you do that? 21 sine squared theta cosine theta cosecant cubed secant. Okay. Sine squared theta cosine theta cosecant cubed secant. Okay, so they give you so much stuff and say, how can I possibly do all this? Well, our favorite trig functions, I know for many of us, you don't like any of the trig functions, but if you had to pick the two, nicest ones, I guess it'd be sine and cosine, right? We tend to be more comfortable with sine and cosine. We don't like the others that much. So let's write it in terms of the reciprocals. Leave these alone. Cosecant is the reciprocal of the sine. Remember, one has a co, the other doesn't. So reciprocal of cosecant cubed is sine cubed. Reciprocal of the secant is cosine. All right. Cancel, cancel. Sine squared, sine cubed, cancel, leaving me with just a sign on the bottom. All right. So there it is. I've written it in terms of sine and cosine, but then simplify after that. So the answer is 1 over sine theta, and go back and change sine. 1 over sine, the reciprocal of the sine is the hint. There's no co, so cosecant. So final answer is cosecant theta. Okay, let me again try to clean out the curl here. So that's what we have. Okay, a lot of these other ones get much more complicated, so we'll try to do our best to get through it. Okay, so 25. You're probably noticing I'm doing just about every other problem. So on paper, you had to do the odds, right? Okay, that's 1, 3, 5, 7, 9. I'm going to try to go 1, you do 3, 5, you do 7, 9, you do 11, at least for this section, okay? So I'm literally doing half the problems. So it's not that hard to do 70%. You only have 20% more to go, so to speak. So right now, at least I'm on the pattern of every other problem. 25, cosine squared A plus cosine A minus 12 divided by cosine A minus 3. Okay, now you should know you can't automatically cancel once you add or subtract something. So don't cancel cosine A, that's automatically wrong. You can't do that. Instead, factor the numerator, and I have a very high suspicion that after you factor, you can cancel the cosine A minus 3 in the bottom. In other words, it's almost like a trade secret. I'm just going to put cosine A minus 3. I've seen enough of these problems that I know the way it's going to work is they're going to cancel these out. Okay, so since I'm banking on that, let's see, how do I go from -3 to -12, +4? So cosine A plus 4. Okay, and yes, you can FOIL this back out. You'll get that. Let's double check this quickly. Cosine A times cosine A is cosine squared A. Outer, 4 cosine A. Inner is -3 cosine A. 4 minus 3 is 1 cosine A, and minus 12. Okay, so big surprise, right? These cancel out. These problems almost always work that way. So final answer is cosine A plus 4. Done. Okay. All right, 29 is one more like that. So secant A, cosecant A. Minus tangent A. Minus cotangent A. Yeah, and you should know, it doesn't matter if they put A or B or alpha, theta, beta, you know, you're doing the same thing. Okay, so they give us the 4 trig functions that don't say sine and cosine. So we'll just change them to sine and cosine and go from there. So secant is 1 over the hint. Secant doesn't have a co, so reciprocal has a cosine. Cosecant, there's a co. Reciprocal does not have a co. Sine of A. Tangent, sine over cosine. Minus cotangent, cosine over sine. So I have this funny thing. I'm going to multiply these two together. So this will have a cosine A, sine A in the bottom. This has one of each. So my common denominator is cosine A, sine A. So I'm going to make all the denominators cosine A, sine A. Okay. So 1 over cosine A, sine A minus sine A over cosine A. So if you're copying what I have, leave a little space here. And this is cosine A over sine A. All right, so I'm writing like this so I can multiply by something. And to get a common denominator, this one needs sine A over sine A, right? This one needs cosine A over cosine A. right? So now all three of my denominators are cosine A, sine A, right? Oh, this is a clever problem. That means, okay, they all have the same denominator now, right? Cosine A, sine A, cosine A, sine A, cosine. So I can write it like this. 1 minus sine A, sine squared A, minus cosine squared A. Interesting. That kind of looks like an identity. Page 504, number 1, sine squared theta plus cosine squared theta equals 1. It says theta, but it can be any letter. It can be A, B, theta, alpha, beta, whatever. I see this here, a minus and a minus. I can factor out the negative, make it look like this. 1 minus parentheses, sine squared A plus cosine squared A over cosine A sine A. Okay, see what I did? I factored out the negative 1. And now I have this thing, which does look like the identity. The identity. This is equal to 1. So I have 1 minus 1 over cosine A sine A. 1 minus 1 is 0. 0 divided by cosine A sine A. And 0 divided by anything except for 0 is 0. Okay. All right, so that's how you do those kind of problems. All right, so now that we got those problems out of the way, the rest of the problems are very good practice for the exam. They're very similar. Okay, one nice thing about the authors is there's a lot of repetition. Okay, so even though we're not quite sort of, testing you on chapter 7, there's a lot of review stuff. Okay, like 33. So the rest of the problems are kind of a nice review for the test. So we're kind of reviewing for the test already now. So 33, if sine of theta is negative 3/5 and theta is between pi and 3 pi over 2, compute cosine theta and tangent theta. It could ask, find all the other 5 trig functions, right? So you might get a question like that on the exam on Thursday. Okay, so let me put down the essentials and go from there. So sine of theta was negative 3/5. Okay, I'm not going to copy all that they have. Let's just think of what quadrant we're in. Okay, so look at 33. Theta is between pi and 3 pi over 2. Number 33. What quadrant am I in? Between pi and 3 pi over 2. It's quadrant 3, right? Zero, pi over 2, pi, 3 pi over 2, 2 pi. We're between pi and 3 pi over 2. I'm in quadrant 3. The sign of the sine, SIGN, SIGN of the SINE is negative. The cosine is also negative. All students take calculus. Okay, so I know the cosine is going to be negative. Okay, use my identity. Sine squared theta equals 1. Plug in negative 3/5 right there. Equals 1. Nine over 25 equals 1. Subtract. One minus 9 over 25, 16 over 25. Remember, this is like 25 over 25, right? Do the square root property. We already said the cosine is negative. So negative square root of 16 over 25. So negative 4/5. Okay, that's that. Then it asks for the tangent after that. It could ask you for all the trig functions, but you know, you should be happy if we get the others. The reciprocals, you just flip them, so no big deal there. Tangent is sine over cosine. So that's negative 3/5 divided by negative 4/5. Two negatives make a positive. Cross off the 5s. 3/4. Right? Okay, so that gives a bunch of problems involving that kind of stuff. Okay, it's a little bit harder because sometimes they give us the uncomfortable trig functions like 37, give you secant. So go in terms of the reciprocal. Okay, compute cosecant and cotangent or whatever. Okay, so here we go. 37, secant beta. Beta is that funny looking b. Negative 17 over 15. Let's figure out what quadrant we're in. Beta is between pi over 2 and pi. Between pi over 2 and pi, quadrant 2. Sine, S-I-N-E, is positive. Cosine and tangent are negative. Okay, keep that in mind. All right, I don't like secant. Let's take the reciprocal. Reciprocal of the secant is cosine. Remember, one function has a co, the reciprocal does not have a co. Cosine beta is, flip it, negative 15 over 17. All right, use the same identity. Just changing the letter. It doesn't matter if it's theta, beta, alpha, you know, A, B, same thing. Sine squared beta plus cosine squared beta equals 1. Put negative 15 over 17 here, right? Sine squared beta plus negative 15 over 17 squared equals 1. By the way, this will always come out to be positive. Even if they give you a negative, you're squaring it, right? Sine squared beta. You can punch it in your calculator. 15 squared is, oops, should be a plus here, my bad. 225. 17 times 17 is 289. That's a 17 there. Subtract. 1 minus 225 over 289 is 64 over 289. Square root, square root. The sign of the sine is positive. I'm in quadrant 2. All students take calculus. We established we're in quadrant 2. So I want the positive value. Sine is 8 over 17. All right, then answer the question for 37. Ask for cosecant and cotangent. Cosecant is the reciprocal of the sine. So I just flipped that. 17 over 8. Cotangent, well, Tangent was sine over cosine. So cotangent is the other way around, cosine over sine beta. So cosine was negative 15 over 17. Sine was 8 over 17. Recurring thing, this happens over and over and over, right? This denominator is same as this denominator, just ignore it. So negative 15 over 8. Final answer for that one. Okay. Okay, one more of that type of problem. 41. This is something that we might get on the exam for sure. Okay. Use the given information to determine the remaining 5 trig values. Okay, so 41 cosine theta is negative 3/5, 180 less than theta less than 270. So what quadrant are we? Quadrant 3. In fact, they seem to be repeating the numbers. We already did that, right? 3/5. The other number are going to be 4/5. Okay, the algebra is pretty much identical. Okay, so if you don't mind, I'm not going to do that algebra. It's very similar. Okay, one was 3/5. The other is going to be negative 4/5 actually. So let's put that down. 41. Cosine of theta was negative 3/5. And again, it said the angle is between 180 and 270. Quadrant 3. Quadrant 3, tangent's positive, sine and cosine are negative. So if you don't mind, I'll just go tell you the algebra is the same. It's going to come out to be negative 4/5. Okay. The algebra is very similar to that, so I'll skip that. I'll just go straight to my chart. So negative 4/5. Cosine is negative 3/5. Tangent is sine over cosine. That divided by that. We know the way the game works. 5 cancels out. 4/3. And reciprocal, reciprocal, reciprocal. Reciprocal of the sine is the cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. All right, flip, flip, flip. Negative 5/4, negative 5/3, and positive 3/4. And yes, you would do me a great favor if on the exam you can list any problems exactly like this when it says, give the other 5 trig functions, give the 6th one anyway, and always go sine, cosine, tangent, and the reciprocals are over here. So it's easy for me. So don't have me looking all over your paper. Oh, where's the sine? It's over here. And where's the cosine over there? And the tangent's over here, right? So just give me a nice organized list of all 6 of them lined up: sine, cosine, tangent, reciprocal of the sine, cosecant, reciprocal of the cosine, secant, reciprocal of the tangent. So if I line up here, I can just look at it very compactly so I don't look all over your paper. Hey, where's the sine? Where's the cosine? Where's the cosecant? And so on. Have it nice and neat and organized like that. Okay. All right, then the last problems are the identities. Okay, and you might have some of these too. We've seen this before. So this is a nice review for the exam already. Okay, I'll do some of these identities. We'll break, and then after the break, I'll do some more. Okay, so prove the equations are identities. All right, so thanks. Some of these look like repeats. That's okay. No harm in repeating stuff. Sine theta, cosine theta, secant theta, cosecant theta equals 1. Okay, we're not solving for theta. Later on, we're going to be solving for theta, but not now. Prove the left side and the right side are always the same. Okay, so you draw an impenetrable barrier, so to speak. Here, there's nothing to do on the right side, right? 1's already good. Well, let's change everything to sine and cosine. leave that alone. Let's change that and change that. So sine theta, cosine theta, secant 1 over the cosine, cosecant 1 over the sine. Cancel, 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 cancel. That's pretty easy. You get 1, and there it is. They're equal. Remember, the reason for this line here is it means you cannot cross that barrier until they're exactly equal. So you're not allowed to, quote unquote, do the same thing on both sides. So for instance, you look at this and say, hey, how about multiply both sides by cosine theta? That's not allowed. Divide both sides by 2, square both sides. Those are not allowable operations when you're proving an identity. Okay, work on one side, work on the other independently, and then hopefully they end up matching. Okay. $49 looks like something we've seen before, but that's okay. If you see it twice, then that just means it should be more comfortable on the exam, right? They got it in parentheses, but they didn't really have to. 1 minus 5 sine x. They write it like this, slash cosine x equals secant x minus 5 tangent x. Okay, let me rewrite this as 1 minus 5 sine x over cosine x. How about let's just change everything to sine and cosine. Secant is 1 over the cosine x minus 5. What is tangent x? Sine x over cosine x. What do you know? I have a common denominator, put them together, and I can see it's going to match, right? 1 minus 5 sine x over cosine x. And there it is. So obviously they match once again. Okay. All right, it's almost 12. We'll go ahead and break as usual. So I'll break until 12:10. We're probably going to finish early. So think of any questions you might want to ask during the second half. And if not, then we'll just go ahead and quit early after that. Okay, so I should be done after 10, 15 minutes after the break. Okay, so let's break until 12:10 as usual. Okay. Okay, folks, let's pick up where we left off. I'll do a few more problems. It should not take that long. And then I'll let it be a question and answer session for review, which is optional. If you don't have any questions, then you can just leave. Okay. And tomorrow, if you have any questions, bring it up again. Okay, so just like the last exam, Thursday, I'll probably lecture very, very little, if at all, then turn it over to question and answer session. Okay. So on paper, the exam is from 12:10 to 1 o'clock. But again, if you want to start early, which helped a lot of you last time, you get an extra half an hour or something like that. That'll be perfectly fine by me. Okay. All right. So continuing on, doing every other problem, I'll do 53 right now. So 1 minus sine theta secant theta plus tangent theta equals cosine theta. I'm going to put cosine theta way over here. So when I draw my line, I mean, there's really not much to do over here, right? So I won't bother with it. Okay, let's change everything to sine and cosine, and then I'm going to FOIL it out. You could FOIL it out right away, but I'd rather just change everything to sine and cosine first. So 1 minus sine theta. Okay, secant. Secant is the reciprocal of the cosine. Tangent, sine over cosine. Common denominator. 1 minus sine theta, 1 plus sine theta over cosine theta. This looks like A minus B, A plus B, does it not? A minus B, A plus B. I'll sneak in a little timeout here, little sidebar. A minus B, A plus B is A squared minus B squared, right? So this gives me 1 minus sine squared theta over cosine theta. And there we go. 1 minus sine squared theta is the same as cosine squared theta. And I can cancel these out. Cosine theta, cross over. Okay. So again, here's an instance where you only want to work on one side. You don't really want to work on both sides. So there we go. Yeah, sorry, I may not have raised it up so you could see it again. So let me run through that quickly. And everything that I've done today, raise it up for better focusing. Okay, again, so if you want to watch the video later, say, the stuff I did was not focused. So you can look back at the video if you need to. I know I'm going fast here, but you can always pause the video and go forward or backward as much as you wish. Just give you a sliver of a moment where it's focused. And let's see, there's that. That. Okay. And then this side, everything that I've done so far, and if I remember to do the last ones, then I'll try to also. Okay, so we're caught up. All right, 57. Sine A plus cosine A equals this monstrosity here. Sine A over 1 minus cotangent A minus cosine A over tangent of A minus 1. Okay, it looks like something we've done before. But that's okay. Let's try to do it again. So it doesn't look like there's anything to do on this side. I need more space to do this. So I'll tell you what, even though I'm drawing a line, I'm going to draw it in a funny fashion like this. You know, I don't want to waste all that space for nothing. So this means it's all on the right-hand side. I'm not doing anything to the left. Sine A plus cosine A, that's about as good as it gets. Okay, so all my work is going to be on the right-hand side, it looks like. Okay, let me change that to cosine over sine. Change that to sine over cosine. So sine A over 1 minus cosine A over sine A. I'm going to leave a space. Cosine A over sine A over cosine A minus 1. Okay, so what did I do? I changed cotangent to cosine over sine, changed tangent to sine over cosine. Okay, now this looks so weird. So let's multiply this one by sine A over sine A, this side by cosine A over cosine A. So at least I can cancel out that and that. Okay, so sine A over sine A, cosine A over cosine A. Remember, all of this is on the right-hand side. I'm not going to touch the left. But, you know, I don't want to just waste paper either. So, and of course, you can do likewise to me on any homework or quiz or test. All right, so that's going to be sine squared A distribute 1 times sine A is sine A. And over here, sine A cancels out, minus cosine A minus cosine A. Cosine A is cosine squared A. Distribute, cosine A cancels out. Sine A minus cosine A. Common denominator. So I can combine the top. Sine squared A minus cosine squared A over sine A minus cosine A. This looks like the difference of two squares going backwards from here, right? A squared minus B squared, I can factor back into A minus B, A plus B, or A plus B, A minus B. So this is sine A plus cosine A, sine A minus cosine A over sine A minus cosine A. Difference of squares, A squared minus B squared, A plus B, A minus B, or A minus B, A plus B, same thing. And there it is, cancel, cancel. Sine A plus cosine A. And that does match the left-hand side, so swing over here. See, they are now indeed equal. So I didn't touch the left-hand side. Usually you can tell if one side is very easy, then, you know, don't do anything with it and just take care of the other side. Okay. All right, so that's 57. Let me raise that up again before I forget to do it later. Okay, so hopefully you can see that. All right, just a couple more, I think. 61. Sine A tangent A equals 1 minus cosine squared A over cosine A. Draw my barrier. Tan A. Tangent is sine over cosine. Multiply these out. Are these equal? I already got the denominators the same, cosine A. So I'm finished if the tops are the same, and they are. 1 minus cosine squared is indeed sine squared. There it is. They are equal. So that wasn't too bad. Worked both sides. So as a reminder, we have sine squared theta plus cosine squared theta equals 1. This is a sidebar. Okay. So that means if I subtract cosine squared theta on both sides, you also have sine squared theta is 1 minus cosine squared theta. And likewise, if I start from the beginning and subtract sine squared on both sides, you could also say cosine squared theta is 1 minus sine squared theta. So these are just variations of the same thing, right? Okay, so sine squared theta plus cosine squared theta equals 1. Subtract cosine squared theta on both sides, it looks like this. If you start at the beginning and subtract sine squared on theta on both sides, you have this. Okay, so be ready to use either one as necessary. Okay. All right, 65, and I'm done, folks. So this is the last one. So I'll be done in a few minutes, at which point I'll let you ask any questions. But if you don't have any, then you can just leave. Okay, and prepare for the test on Thursday, naturally. Okay, this one does look a little bit bigger, though. Sine A minus cosine A divided by sine A. Okay. To set this one up, you can look at 65. I'm not quite going to write it like 65 because I see the denominators aren't common. I'm going to leave space for me to put down a common denominator, okay? So I am copying it, but I'm leaving a space. The next one goes cosine A minus sine A over cosine A. And then it goes equals 2 minus secant A cosecant A. All right. I should have left more space over here, but anyway. Common denominator is sine A cosine A. So cosine A cosine A. On this side, sine A sine A. I should have left a little bit more space, but I was running out of space as it was. Okay, now why did I do that for? To get a common denominator of sine A cosine A, right? And the right-hand side, let me just write it as 2 minus secant is 1 over the cosine. Cosecant is 1 over the sine. Okay. So it looks like I had to get a common denominator anyway. So why don't I just combine this to get a common denominator? So I'm working on both sides, left side and the right side. 2 minus 1 over cosine A sine A. 2 is like 2 over 1. So how about multiply this side by cosine A sine A? Cosine A sine A over cosine A sine A. It does help that I see there's going to be cosine A sine A in the bottom here too. So hopefully all the junk on top comes out to be this. So now the right-hand side is probably going to be as good as it gets. 2 cosine A sine A minus 1 over cosine A sine A. Right? So my goal is to make this side look like that. So let's see if it works. In fact, I already have a common denominator, right? Cosine A sine A, cosine A sine A. So since I have a common denominator, let me just write one great big fraction, cosine A sine A, and just multiply out the top. And I hope after I multiply it all out, I get something that looks like that. So let's see if I do. So distribute sine A cosine A minus cosine squared A. Distribute cosine A sine A minus sine squared A. Okay, I look at what I have over here. That's not cheating. I'm not doing the same thing to both sides. Like I'm not multiplying both sides by 2 or dividing both sides by 7 or squaring both sides, but I am peeking over here to see what I need. I see sine A, cosine A. There's another sine A, cosine A. So there's 2 of them. That helps. So I can get that one and that one to be -1, and then I'll be done. And it looks like I can. Right? So this one and this one are the same. One of them is written backwards. That says sine A, cosine A. This is cosine A, sine A, but that's the same thing. So 2 cosine A, sine A. And then this one and this one, negative cosine squared, negative sine squared. If I factor out the negative SIGN, I get this. Okay, so one more time. Sine A, cosine A, cosine A, sine A. They're the same thing, so I have 2 of them. Then negative cosine squared A minus sine squared A, factor out the -1, negative cosine squared A plus sine squared A, and there it is. We know that's equal to 1, so we got them to be the same. So 2 cosine A sine A minus 1 over cosine A sine A, and there it is. They are equal. This one's a little bit harder because you have to work on both sides, but it works fine otherwise. Okay. All right, folks, I'm finished. So my goal was 7.4. I was able to finish that. Okay, so we are here. All right, so tomorrow, 7.5, and I'll let you ask questions if there are any. Okay, the exam is on Thursday. I'm not sure if I want to go ahead with this. I still have all these buffer days here, so I may not want to start 8.1, start using up some of these buffer days, as the case may be. Okay, all right, I'm going to stop the share, and we are now officially finished, folks. All right, so in the next 2 or 3 minutes, you can either stick around and ask me questions, or if you have no questions, you can disappear, and I'll see you tomorrow. Okay, so you may leave or you may stay. If you want to stay, then ask me stuff, and I'll stop the recording also. So no longer recording.